welcome back to Wanna Watch Me Code. I'm back for more today because I'm pretty bored and just feel like keep working on this. So to recap where we left off last time, we created the message broker and we got it to the point where it will handle all inbound and outbound UDP messages that come in, and basically coordinate the health check requests and responses between peered servers. We showed that we were able to invoke the message broker and saw that the request was made and it was received on the other end and logged. But we, beyond that, are not doing anything with that request. So one of the things that we want to do, as outlined in step 4, right? So we want to have the remote host that we're pinging and trying to get the health status of, it's getting that request right now, but not doing anything with it. So we want to write a handler that gets that request and then sends an acknowledgement request back to the initiating host, like the one checking the health of the remote host. We're going to go about doing that. Another thing that I kind of want to do this time is take a look at the performance of it. So we'll use we'll hopefully be able to use the performance Linux command to show what instructions are executing, maybe try and capture some network traffic to show the size of the packets being sent back and forth, because that's kind of the goal of this project, is to get optimal performance and be very resource conscious and use as minimal amount of our computing system as possible. Part of that, the main reason for that is this will be one of the most critical aspects of the decentralized network. So as the network grows, and we'll at a certain point we're going to have to think about a lot of things, but as the network grows, we're going to be performing more and more health checks potentially to maintain our context of the network and what's on the network and what's available and what might have left the network and kind of determining all of that with these health checks. So I wanted the packet size to be extremely small, which is why we went with UDP and a custom protocol, like no HTTP overhead, things like that. So let's get to it. So again, we got the message broker created, and we basically have no message handling beyond that point, aside from our proof of concept for just quickly testing if it's working at all. So we're going to go ahead and create those handlers, and hopefully by the end of this, the health check end-to-end process will be hopefully complete, and we'll be at a point where we can start actually building out the network, the network table, basically knowing what devices are on the network, and we can kind of build that context, and that'll be in a follow-up video, and that's going to be kind of probably the coolest part, and show you what I'm actually trying to do. So let's get to it. I'll open up the code again. Let's see, I'll save this. I actually got around to saving this, and it will be included in the Rust package when I finally commit it to the repository. So let's just actually check what we actually did so far and don't have committed. So we created a couple files, modified them, and it's kind of where we're at. Got the notes for the episode there. I also want to restructure this and kind of pull out, like, segment some of this stuff into different files that a way that makes sense. But it's already kind of pretty lightweight. You know, like the actual logic is only really 80 lines. So that's not too bad. So it might just never touch this, but we'll see. Anyway, not the point. Last we touched was the network broker. Let's get rid of some of these dependencies that we're not actually using. Just clean that up. Let's go here. Yeah. I'm just gonna clean up some of this stuff, so that we are clean and don't have confusing comments of commented out code and stuff. Kind of the goal of this, so like this has probably been really boring for a lot of people, but my goal for this channel and like this straight up account I have on my laptop, the Wanna Watch Me Code account, is to stream as much as possible of exactly what I'm doing, so that anybody can follow along and see the entire everything that was done to get to whatever point of the project. So I've been not really touching this outside of the videos, and that like kind of, you know, causes a little pain, because now you're watching me go through and clean up stuff that really could have been done not live. But you know, I'm just gonna leave that comment. Actually, it's fine. Okay, anyway, screw this. It's fine. So alright, so let's go ahead and create a new file. We'll call this health check broker. What do we call this? This is I guess network broker handlers. I guess should be good. And okay, so right, so the network, let's say I write some comments. So the handlers, their responsibility will be to listen to a receiver channel, and then process broker message, and like handle it, and so for handling it, for example, on a SYN request, we will send back an ACK. On a ACK request, we will in the future, so put to do update the network table, or whatever it will be, data store, whatever. Like I don't think it'll be a database, but like, you know, like a map with a certain structure that is like virtually the equivalent of a database with an abstraction layer. I don't know, but we're not at that point yet. So right now we're just going to focus on sending of the acknowledgement, so that whoever perform the health check now knows, like, okay, that host is alive, we got an ACK, like they're good, and then, you know, take action on it, add it to the network table. But I for this I want to receive the initial health check request and then send back the ACK, and that's kind of the goal of this this episode, I guess. So ACK request, and then no up, right, would just like log just log unexpected message or something. So yeah, there we go. So let's define a handler, right? So we'll do struct, like, I don't know, I kind of want to make it abstract, but right now I'm just gonna do, you know, very specific to the health check. So we'll do health check. What are we gonna do actually? What do we call this? Health check. Health check. what did I call the message packets, right? Let's go here. Oops. I'll check network handler. There we go. Stay consistent. What will this contain? It will contain a request receiver channel. It'll kind of be very similar to the message broker, right? So response sender, and we're gonna name it a little different, I guess. Actually, no. I mean, maybe we should stay consistent and make these exactly named the same. We don't need the socket address at all because we're not actually going to be operating on it. We're just going to be taking messages from one and then processing and sending the result to the other. So no, I should name these differently. It'll be very confusing if I keep them the same. So response sender, request receiver. So okay, so we'll do response sender. So let's do response receiver, and then we'll do request sender, right? And so let me take some notes here, add some comments, right? So oh wait, is it, what does this do? Okay, I don't know what the comment structure is on this, but receiver from the network broker. Actually, I'm gonna just name this appropriately. Network broker receiver. Network broker sender. Okay. So we got that. Sender to the network broker. Good. Now we got that. That's our two channels, or sender and receiver for the channel that we need to operate on. So now what? We're going to do something very similar probably to what we did in the actual broker, which makes me think, like, is there a way we can kind of create a generic interface, or, well, I guess, yeah, like, say, in, like, say Java, for example, like creating a generic interface that we could just implement, like, the same like kind of methods, like a receiver method and a sender method, and then like these could kind of just share that base class and override, because like really the only difference between this here and what we're gonna be doing I think is just literally this this method here, because from a high level all we're doing is listening to what are we doing? We're like spinning up threads to receive and send. Actually, it would be different for the one we're doing, because that's not really. Yeah. Okay. Anyway, I don't know where I'm going with that. 1 second. Okay. Let's go. So let's do impl health broker message handler. Okay. And we'll do it. Let's see, how do we do this? Gonna do the new method. It's gonna be very similar to the socket address. Go here, do delete that. We're gonna do network. Hold on, let's copy this. Go here, go here, go here, delete some stuff, get rid of the comments, and this is not that, it's health check, network broker handler, and I'm going to do network, like that, just like that, like this, and not sure why they're red there, but Why is it red? Oh, because I am doing message handler. There we go. There we go. So we got our constructor going. What are we gonna do? We're gonna do this is not really actually a handler. This would be like a listener. Alright, so but anyway, okay, so let's actually rename this. Refactor, rename, listener. Make it a listener. Name it a little better. And so this will be ready. We'll do a pub fn run, and we'll do basically probably the same thing we're doing in here, right? Receiver handler. Okay, response sender receiver socket. Let's just do basically the same thing. Follow the same naming convention. Get rid of all the insides. Let's make sure. Don't need that. Don't need that. And we're going to do self dot okay, so can't do, we don't have self yet. Self dot network receiver that receive let next message equals self. Okay, let's name this in the proper naming convention. Next message. Right, and then we'll do something like process. Yeah, let's see. Let's see. I wonder. So I'm thinking, like, do we have? Do we like, I'm thinking, like, should the message broker, right, should it really have a collection of receivers, and within here it figures out which say opcode it has, and then forwards it downstream to the appropriate consumer. What I was thinking was, like, this would, I like the way I did it here, where it's just there's one receiver and one sender channel, and I was thinking of having one receiver, like, so like the sender here, like whatever the receiver of this is, would perform that action and maybe do fan out, and then within that one receiver it could have a collection of handlers, and then just trigger the appropriate handler to handle that message. So I think we'll do that. I think this this message listener, we can just basically register a bunch of handlers, and depending on the opcode, we would route to one of the handlers that is appropriate for that opcode. So like a sync acknowledgement handler would be have like a sync request like routed to it, and it would handle it, and then an ACK handler would just do whatever, like whatever it's gonna do, and then a no op would just log or something and say we got a no op until we have a reason for that. So yeah, so that's new there. So next message. Cool. Let's go. Self network broker receive. Okay. Okay. Okay, so let's do pub handle message, and we'll get the let's see. This is the health check. So message, health check, message, health check. Self health message. Equity public fund. Health check broker message. And I don't know. It might be void. We'll see. See what happens. And so, how do we do that map thing? 'Cause there's so much trouble with the map. I want to use a map and just do a key value lookup for the opcode to the message handler and just fill that map up with all of the potential handlers, and that way we get just a one lookup of what handler we need to invoke, and then if it's not in there, then it'll be an O1 cost to determine if it actually contains the proper opcode, and if it doesn't, then we handle it as an unexpected scenario. But what do we do? How do we? Okay. Oh wait, no. What is it? Okay, so it's the test. Where is the map that we created? Hash set right here. Okay, so I can do something like this. I don't like that though, because I wanted a const so bad because this feels like it's going to have to create a new hash map every time. But I don't know if that's what it really does. But for now, I don't know. It'll be like a good optimization if I can figure out how to actually do it the proper way I want to do it. But so get health check handler map, and then this will be a hash map instead, and then it'll be how do we do this? Is this even a method? Expected I gotta do hash map u8 and then fn. Can I do that? Can I? What is that? Expected. Oh. Ooh, nice. That's cool. And this will be message health check message. Okay. From okay, so this is from, and what does it take? I'm not sure. Okay, fill in missing arguments. Oh jeez, come on. Okay. So whoops, inline hash map Rust. If you create a macro, then you can call it like the following. I'm gonna try this, right? Let's see if that works. I don't know if functions are clonable though. Actually, can I just do what they? So okay, let's go here. Health checks in opcode, and then we'll do health check message, and it's going to be a health check broker message, right? So now let's see if we can do this. Health check SYN opcode handler. Cool, might work. Okay. And then we got, what else do we do? Health check, ACK opcode. And then, let me just copy this whole thing. Health check SYN opcode handler. And then this will be ACK. ACK opcode handler, there we go. Health check, ACK opcode handler, like that. And it doesn't look like it's happy about that one. Okay, I know what I have to do. I think it's like that type of thing where, so if I delete this, well, how does this work? From, alright, let's do some experimentation. Let's go, let's do a test. Network, nope. Health check network broker, nope. Health check, let's copy the test. Okay, let's go here, test. Let's just copy from there to here. Okay, let's go there. Okay, got that. Delete the contents. I'll do check. Health check handler. Contains handlers. Okay, so we'll do let handler map equals get health check handler map, and then we'll do what do we do? Assert or let's go, no, wrong one. Let's go here, health check. Okay, assert equals delete this, I'll do handler map dot get health check, okay, and we'll make sure it's equal to health checks in opcode handler. So this is convert to annuate using and. Okay, so I guess I gotta pass by reference. Cool, looks like it might work. And we'll just do this as well. We'll do no op or health check. Health check. ACK opcode handler. There we go. And then let's actually do a no op too, and then it'll just be default. No op. Okay. So we'll do the first one as no op. No opcode. Health check. Okay. Looking good there. We'll just add a test for the no op. I'll check. No op code, yeah. I'll have to rename that probably. I'll check. No op code handler. Okay. Now let's see if it'll compile and I can run that. Nope. Let's see. Okay, that should be that. Let me shut that down too. Okay, let's run it. Forgot that I left this here that can only be used dot expect. Let's see. Okay. What's that? Let's do this. What's that say? The trait bound hash map from the trait from UAFN. So like this. What? Okay. Well, let's just do it the easier way. New. No, not return either. Let mutable mute map equals map dot put set add set did that. Push. What? What is the? How do I add to it? Oh, is it just the notation? No, opcode equals. How do you? So, map insert. Okay, it's right there. Geez, dot insert. I got that. There we go. Map dot insert. Health checks and upgrade. That's not the right one. Map dot insert. Health checks and upgrade. Health check. Checks and upgrade handler. Why is that wrong? I don't get it. Type mismatch, expected health check. Oh, okay. Weird. Okay. It's annoying. Oh, maybe I can, hash map U8 message. Health check message, break message. Cool. That freaking worked. That's pretty sick, dude. Okay, and then we'll just do this. Ready? We'll do return map. And I know like the difference between this and this is something, but let's try that and let's run it. Mismatch types. expected option. Oh, okay. So it's got to be unwrap. Dot unwrap. Dot unwrap. There we go. Let's try that again. Oops. Whoops. Okay, left value that as fun. Okay, what's it say? Assert equal expected fun pointer. Found fun item. Fun items are distinct from fun pointers. Do I have to consider casting to a fun pointer starting? If left up val pointer. So this is a. So maybe if I did a pointer to it, right? Maybe. I think it's this, right? Why did it, do I have to... Okay, let's get rid of that. Why? This. Try that. Compiling. Mismatched types. Fuck me. Okay, expected fun pointer, fun health burger message. Found an FN item. Which one though? Is it the left or right? What are these? Can I do like a search? See what this does. Really, I just only care about if they're there. I mean, ideally, like, I would want to check if they're the same, but I don't understand. Cannot apply on unary operator. Let's see, what is search? Okay, let's just ready. I'm gonna test something. Let's go here, run that. I don't know if it's gonna complain about there being no asserts or not, but and it passed. Okay, so now let's try and just see if I try and get something that's invalid, unwrap, and we'll do. Actually, it's got to be, and say 10 and 10. As U8. Okay, I don't know if that's even makes sense that I was used a pointer to 10. It's like a pointer.